Hello, Mr. Barton here, and in this video I seek to answer the question, can you use diagnostic questions for multi-step questions? Now I know what you're thinking. Any of you who have watched my golden rules for what makes a good diagnostic question video will be thinking, well, one of your rules says you can't use flipping multi-step questions, so what are you going on about here? But if you break them down and you ask them in a real clever, carefully considered way, then you certainly can use diagnostic questions for multi-step questions, as I hope to show you in this video. So let's take this question, a classic question that would appear on a GCSE exam. Solve the simultaneous equations. Now, how many marks would that be? Maybe 4 marks, maybe even 5 marks? Just think of the different mathematical skills that are involved in solving simultaneous equations, and feel free to pause the video and try and list them down. Are you back? Okay, well let's think about it. We've got to be able to manipulate algebraic expressions. Then we've got to be able to add and subtract algebraic expressions. Often negative numbers are involved, so we've got to either be able to add and subtract negative numbers or multiply and divide negative numbers. Then we tend to get a linear equation that we need to solve. Then once we've solved that, we need to substitute back in. So we're already up to 5 or 6 different separate skills. So there's no point whatsoever in me just asking that question and then saying option A, x is 5, y is minus 2. Answer B, x is 3, y is 2. Doesn't tell me anything because I don't know where in the process they've gone wrong. But what I can do is I can break this down into several diagnostic questions. So let's take the same question and instead ask this. Step 1, which of the following is a correct first step to eliminate y? So there's no point carrying on with the rest of this question unless students can get this first bit right. So can they manipulate the algebraic expressions? And then what I do when I ask them the second question is I tell them the right answer to the first one so that everybody's back on a kind of level playing field. Because with traditional ways of asking questions, if you get the first step wrong, you're probably not going to access any marks, but you may only have one misconception in that first step and you may do the rest perfectly. So this way of questioning allows you to identify where in the process the child goes wrong, but also give them chance to demonstrate that they can access all the other stuff instead of you just thinking, they're useless at simultaneous equations. They may only have one little mistake. They may be in the same position as the child who gets the very last step wrong, but gets 4 out of 5 marks. Well, this may be the same. The child may get the first step wrong, where they can still demonstrate to you that they've only got one misconception. You can see I get a bit carried away with this kind of stuff. So what's the next correct step? So now I'm testing whether students can add or subtract algebraic terms and negative numbers. Tell them the answer to that. Now what's the next correct step of the method? Can they solve linear equations? Now they've got the answer, x equals 4. Do they know what to do now? Do they know to substitute? Once they've substituted, can they then solve that equation? And then once they've solved that equation, do they know if they've got the final answer? So 6 steps for one question. But by students answering that is going to tell you so much about where you need to focus your intervention for simultaneous equations. As I've said, and I know I sound like a broken record, it's not just the case that students can do simultaneous equations or can't do it. They either can do it or they can't do it for very specific reasons. And this process allows you to identify those reasons. Here's an alternate way of doing it though. Very, very clever question this. I really like it. So presenting students with a pair of simultaneous equations, presenting them with a solution and saying, where does the first error occur? So a similar process, but gets it done in one question. I like that as well. Let me show you one other example. This was a classic. So I've adapted this from edXL's June 2014 higher paper. I think in the original paper, I think were cows involved maybe? Well, I've used my imagination. I've changed them to horses, so it's absolutely an original question here. So we've got Karen keeping horses in a field. Now, these are the kind of questions that I certainly find my students struggle with, these unstructured questions where it's not immediately obvious where they need to start. Can you ask these as diagnostic questions? Well, yeah, you can, because you can break it down. Step 1, what's the missing length? Step 2, what's that missing length? Because if they can't get that, they can't do the question. Then show them what those answers are and then say, okay, what's the area of the field? Then tell them the area of the field and say, okay, now how many horses can Karen keep? You've broken that question down into 4 separate skills, and depending on your students' results to those 4 skills, how they answer it, will tell you the specific misconceptions that they've got. So In conclusion, you certainly can ask multi-step questions using this diagnostic questions method. It's just a case of breaking the question down into smaller steps which allow you to isolate specific skills or concepts. Anyway, hope that was useful. Take care and bye for now.